Hello student, myself Kanchan Vishramji Kumbhalkar, Department of Chemistry. I start first unit of analytical chemistry, that is thermoanalytical methods. First of all, welcome you all. Hope so all of you are very safe. So let's discuss about the syllabus. In unit first, there are the thermal method of analysis has been discussed. There are various 4 different types has been mentioned. First one is the thermogravimetry, TG, DTG, DTA and DSC and its whole factors, application, etc. So let's start with that of the thermogravimetry and DTG. So what is meant by thermogravimetry? Thermogravimetry contains 2 different words. First one is the thermo and second one is the gravimetry. Thermo means it is related with the temperature and gravimetry it is related with that of the weight of a substance. So when the weight get affected by the temperature, or what is the effect of temperature on a weight of a substance that has been analyzed, then it is considered as the thermogravimetry, in short TG. So thermoanalytical method may be defined as those technique in which changes in physical and or chemical properties of a substance are measured as a function of temperature is called as the thermogravimetry. Means the effect of temperature on a weight and that has been get recorded as a function of temperature is considered as that technique is known as the thermogravimetry. Next point, differential thermal analysis, DTA. Differential thermal analysis is a method for recording the difference in temperature between a substance and an inert reference material as a function of temperature. Now in a TG, when we are considering a TG, we are just using a single same compound which has been under observation. The effect of temperature and its change in weight that has been considered. But in a differential thermal analysis, its name differential means there are 2 substances has been taken. First one is the sample and second one is the inert reference material. Means for example like in a NMR we are using a reference compound TMS. Along with that the signals has been mounted. So similarly in a differential thermal analysis the reference compound inert reference material is also conducted and its changes in weight has been recorded with the function of temperature and sample is also recorded with respect to that reference compound. So that type of analysis is counted as the differential thermal analysis, that is DTA. Now thermogravimetry analysis, obviously the thermogravimetry analysis it is related with the temperature effect on a weight of a substance. So and when the result, when we count what is the weight effect, what is the change in weight with respect to temperature has been observed and that has been analyzed, and now it put it on a page as a form of graph, then that graph is counted as the thermogram. Means what is meant by thermogram? The result which is expressed in the form of graph where the weight has been put it versus the temperature, that is known as the thermogram. For example, this is the typical thermogram. It is the typical thermogram of a AgNO3. Now what is meant by thermogram and what it indicate? This is the basically showing a characteristics feature of thermogram of a AgNO3. Now what is meant by thermogram and what it indicate? Okay, in this case there are 4 points has been given. First of all, there is a weight versus temperature has been put. On x-axis temperature has been taken, on y-axis weight has been taken. There are 4 points has been observed here: A, B point, C point and D point. At a point B, there is a 473 degree Celsius has been mentioned. At a point C, there is a 608 degree Celsius has been mentioned. Now, what it indicate? Now, when suppose we take a X amount of AgNO3, when you are starting a temperature up to the 473 degree Celsius, we increases the temperature, but there is no any change in weight. Means during the line AB, which is exactly parallel with the x-axis, means it indicate that there is no change, there is no fluctuation in a weight of a AgNO3. Means AgNO3 up to the 473 degree Celsius is constant. There is no any reaction, there is no any effect of AgNO3 takes place during the AB temperature. Now, but when we are increasing a temperature 473 degrees Celsius and above, means when we are reach up to the B point and when we are moving toward the C point up to the 608 degrees Celsius, there is something happen due to which the weight loss takes place. Means with respect to the increase in temperature, there is a weight loss takes place. So from that of the 473 degrees Celsius to the 608 degrees Celsius, the temperature increases and the weight loss takes place. The weight decreases. So that BC slope indicate that there is a something reaction, some reaction happened due to which the AgNO3 is not stable in that range and it get converted something into, and due to which there is a weight loss takes place. Something is rejected from the reaction and there is a weight loss takes place. But after 608 degrees Celsius, again we take a parallel line with respect to the x-axis. So CD is a parallel line which indicate that either you increase the temperature above 608 degrees Celsius, it does not affect the weight of that compound. So let's check out what is the reaction, what happened, why, what is the reason behind the first AB and BC slope and then again the CD point. Now this is the reaction. When we are considering above the 473 degrees Celsius and up to the 608 degrees Celsius, this reaction has been occurred. Now below the 470 degrees Celsius, AgNO3 is quite stable. AgNO3 is completely stable. There is no any such kind of reaction has been happened. So due to which whatever X amount of AgNO3 has been taken, that quantity remain constant. There is no any kind of reaction further takes place. But when you are reaching up to the 470 degrees Celsius and when you are moving above that, then this AgNO3, which is in a solid phase, get converted into the silver solid, NO2 gaseous phase and O2 gaseous phase. So in this case, when you are increasing a 470 degrees Celsius and above, the NO2 gas and O2 gas simultaneously slowly rejecting from the reaction, due to which the weight loss takes place. But when you reach up to the 608 degrees Celsius, the complete ejection of NO2 and O2 completely takes place, due to which at a 608 degrees Celsius only the silver remain. Ag in a solid phase remain. And now when you are heating above the 608 degrees Celsius, there is a simple Ag in a solid phase remain, which is quite constant, which is stable, due to which there is no loss of any gas and there is no loss of any weight of that compound. Hence, before 473 degrees Celsius, AgNO3 is stable, it is maintain its weight. In between 473 degrees Celsius 60 up to the 608 degrees Celsius, this reaction has been proceed continuously and it eject NO2 and O2 gas. Hence the weight loss continuously takes place, means weight losses. Due to the loss of NO2 and O2, the weight decreases from point B to C. Now at a 608 degrees Celsius, NO2 and O2 are completely get rejected and now there is a remain of only Ag in a solid phase, only silver alone. So above 608 degrees Celsius, silver doesn't decompose. So above 608 degrees Celsius, the silver remain constant, so weight remain constant. So these are the basic reason behind what is the AB, what is B, why there is a BC slope happened, and why there is again stability during the CD range. Okay, so next example is another example of that of the cupric nitrate hemipentahydrate. Now it is possible that there can be more than one step. In previous example there is one single BC slope has been occurred, but in this case there are more than one slope has been given. There are totally 5 different lines has been given, out of which there are 2 slopes and 3 considered as a parallel to the temperature range. So the same happened when we are considering the A to B, the weight remain constant. From B to C means about from 100 degree to the 150 degree Celsius, it has been counted that there is a weight loss takes place. Again from 150 to the 200 degree Celsius means from C to D, the weight loss is considered as the very minute or negligible, hence the line is about parallel to the x-axis, means it does not have affected with that of the temperature. Again above the 200 degree Celsius up to the 280 degree Celsius, from D to E, again there is a weight loss counted, and from above 280 and above there is no effect of temperature on a weight of substance. So what is the reason behind that? So let's check out. In this case there are 2 reactions has been happened. When we are counting up to the 100 degree Celsius, means when A to B has been counted, when up to the 100 degree Celsius there is no any change. The CuNO3 by 2.5 H2O by solid phase, they remain constant, there is no any reaction occurred. But above the 100 degree Celsius the first reaction has been started, and due to which the 2.5 H2O in a gaseous phase has been liberated, which is the reason of weight loss. So weight loss because of 2.5 H2O in gaseous phase was that simultaneously losing, hence the weight loss takes place. But at a 150 degree Celsius, the CuNO3 by 2 which is formed in a first reaction, which is in a solid phase, is remain constant. Means during 150 degree Celsius to the 200 degree Celsius, the CuNO3 by 2 is remain constant, its weight doesn't change. But when you are increasing the temperature above the 200 degree Celsius, the second reaction has been occurred, the second weight loss takes place up to the 280 degree Celsius. Means from 200 to 280 degree Celsius, the second step has been followed, where the product of first reaction, that is CuNO3 by 2 which is in a solid phase, get decomposed into the copper oxide with a liberation of NO2 gas and O2 gas. Hence during 200 to the 280 degree Celsius, the reason behind the weight loss is a loss of NO2 and O2. But above 280 degree Celsius, the copper oxide which is remain constant, it is remain constant, and copper oxide is much more stable up to the 950 degree Celsius. Hence from 280 degree Celsius and onward, the copper oxide remain stable. So due to this 2 reaction, we get 2 slopes and 3 stable points where there is no weight loss takes place. So this is all about the thermogravimetry and thermogram. Thermogravimetry means it is related with a temperature, and gravimetry means it is related with weight. The effect of temperature on a weight, or the changes of weight with respect to the temperature, is counted as a thermogravimetry, and thermogram means the graph plotted against weight versus temperature, that is known as the thermogram, which indicate the relation between weight and temperature. So this is all about for this lecture. In next lecture we will start with the instrumentation for thermogrametry and factor affecting TGA. So up till that, take care, be safe. Thank you.